Good day, everyone. Welcome to math class. This is teacher Alex, and for today's lesson, we will be tackling about the six trigonometric functions. But before that, let us first recall what is Pythagorean theorem and how can we relate the Pythagorean theorem to our topic, the six trigonometric function. So the Pythagoras theorem, which is also referred to as the Pythagorean theorem, it explains the relationship between the three sides of a right angle triangle. The Pythagorean theorem consists of a formula a squared plus b squared is equal to c squared, which is used to figure out the value of the hypotenuse in a right triangle. The a and b are the two non-hypotenuse sides of the triangle, which are called the opposite and adjacent side. So the six trigonometric functions are simply various ratios between the lengths of the three sides of the right triangle. So now the question again is, how can we relate the six trigonometric functions to the Pythagorean theorem? Let us first draw a figure of a right triangle. This is the right triangle. So it measures 90 degrees, right? So it measures 90 degrees. And if the given angle is located here, so how can we determine the three side? So remember that the opposite side of a right angle is what we called as the hypotenuse. So this is now our hypotenuse, the longest side. This is now our hypotenuse. Next, if the given angle is located here, if the given angle theta is located here, therefore our opposite side is here. So this is now our opposite side. And the remaining side is what we called as the adjacent side. This is now our adjacent. Next. So how can we relate this Pythagorean theorem or this figure, the right angle, to the six trigonometric functions? Again, what are the six trigonometric functions? So the six trigonometric functions, it is sine, cosine, tangent, cosecant, secant, and cotangent. So but first, let us determine the abbreviation of these six trigonometric function. So for sine, it is sin or sin. For cosine, it is cos. For tangent, it is tan. For cosecant, it is CSC. And for secant, it is sec. And for cotangent, it is cot. So now, to determine the ratio of these six trigonometric functions, let us first again recall SOHCAHTOA. Are you familiar with SOHCAHTOA? SOHCAHTOA. Are you familiar with SOHCAHTOA? So when we say so, it is the ratios of the function sine. So therefore, our function for sine now is opposite over hypotenuse. For cosine or cos, it is adjacent over hypotenuse. And for our tangent, it is opposite over adjacent. Next is, how can we determine the other three ratios of these trigonometric functions? So always remember, class, that these remaining three trigonometric functions, it is the reciprocal of the primary trigonometric functions. So to get the cosecant, it is the reciprocal of the ratio of the sides. So it is hypotenuse over opposite. And for our secant, it is hypotenuse over adjacent. And for our cotangent, it is adjacent over opposite. So this is now our ratios of the six trigonometric functions. So for sine, it is opposite over hypotenuse. For cosine, it is cos and the ratios is adjacent over hypotenuse. For tangent, it is tan and opposite over adjacent. And cosecant, it is CSC and hypotenuse over opposite. And secant is sec and it is hypotenuse over adjacent. And for cotangent, it is cot and adjacent over hypotenuse. So now, next, how can we derive the six circular functions using the trigonometric functions? So let us first illustrate a unit circle. Unit circle. This is the unit circle, and let's inscribe the right triangle. Let's inscribe the right triangle. So it is the right triangle. Again, the measures of right angle is 90 degrees. It is, and if the given angle is here. So again, so in this, when we say circular functions, so if it is the illustrations, so again, what is this point here? This point. What is this point? This. So we can see the point of intersection using the coordinates of the unit circle. What is the angle, or what are the coordinates of this point? So again, if it is 45 degrees, if the given angle is 45 degrees, so our coordinates now is square root of 2 over 2 is square root of 2 over 2 and square root of 2 over 2. This is now our coordinates. So since the coordinates is x and y with respect to x and y axis, so therefore our x now is square root of 2 over 2 and square root of 2 over 2 with respect to x axis and y axis. So since in the unit circle the radius is always equal to 1, so our hypotenuse now is what we call as our radius, which is 1. So this is now. So to get the six circular functions, to derive the six circular functions using this figure, we can say now that our since di ba, we already determined the six circular function and its ratios. So for sine no for sine for sine, it is opposite over hypotenuse. Or it is y over the hypotenuse, di ba? It is y and x. So with respect to this figure above, so our opposite is y with respect to y-axis, and our hypotenuse is the radius 1. So this is the hypotenuse, the longest side of this right angle triangle. So this is now our sine. Opposite over hypotenuse is equal to y over 1. And for cosine, it is, what is cosine? It is the adjacent over hypotenuse. It is adjacent over hypotenuse. Or equal to x. It is the adjacent x. And the radius 1, or the hypotenuse. So this is now our circular functions. Next is the tangent. For tangent, it is opposite over adjacent, or the opposite is of the given angle is y, so it is y. It is y over the adjacent is the x. So this is now our tan. Next is cosecant. Remember class that cosecant, it is the reciprocal of the sine. So if the ratio of the sine is 1 over y, so therefore, or the hypotenuse over opposite, so therefore our hypotenuse is 1 and our opposite is y. Next, for secant, it is the reciprocal of cos, so hypotenuse over adjacent. Therefore, hypotenuse is 1, adjacent now is our x. So our secant is 1 over x. Last is cotangent. For cotangent, it is the reciprocal of tangent. So adjacent over hypotenuse. It is equal to x over y. It is x over y. So this is now our 6 circular functions given to the we already now derive the 6 circular functions um, using the 6 trigonometric functions. Okay. Next one is this. This is now if the figure in the unit circle, as you can see in the left side of the screen, it is the illustration of the unit circle, and the right angle is inscribed into the unit circle. So as you can see, this is now our ratio for um, the 6 circular functions. Next is how can we derive again? How can we derive the 6 circular? Diba, since we already determined the 6 circular functions using the unit circle. If the given radius is not equal to 1, so how can we determine the ratio of the circular functions if the given radius is not equal to 1? So again, if the radius is not equal to, so if this is the circle, the unit circle, if it is inscribed, if it is if the given right angle is inscribed in the unit circle and its radius is not equal to 1, it is r, so we can say it is r, our hypotenuse now, and our adjacent, or if the given angle is here, so our opposite side is what we call y with respect to y axis, and it is y with respect to x-axis, and it is x with respect to x-axis. So we can now determine the ratio of the 6 circular functions using the 6 circular. We can now derive the 6 circular functions where r is not equal to 1. So for sine, no, for sine is equal to, diba, opposite over hypotenuse. So our opposite now is our y. So our opposite is our y. And our hypotenuse now is our r. So this is now our uh, ratio of the sine if the given circular functions, if the given radius is not equal to 1 in the circular functions. Next is cosine. Cosine, it is hypotenuse, or no, it is adjacent over hypotenuse. So our adjacent now is x based on the given angle in the right triangle. So our hypotenuse is r, so it is the longest side. Next is tangent. For tangent, it is, what is tangent? Tangent is equal to opposite over adjacent. So our opposite is y and our adjacent is x. So next is the other three are reciprocal of this primary function. So for cosecant, it is the reciprocal of the ratio of the sine, right? So if the ratio of the sine is y over r, so our cosecant now is r over y. Same as in secant, it is the reciprocal of the ratio of the sine. Therefore, our ratio for secant is r over x. Next or last is the cotangent. Next is cotangent. So for cotangent, since it is the reciprocal of the tangent, so since our tangent is y over x, so our cotangent now is x over y. So always remember for sine, it is r is not always equal to 0, and for cos, r is not equal to 0, and for tangent, always remember that x is not equal to 0, and for cosecant, always remember that y is not equal to 0, and for secant, always remember that for secant it is x, where x is not equal to 0, and for cotangent, x is not equal to y. So therefore, this is now our six circular functions, the ratios of the six circular functions given that the r is not equal to 1. Next is this is the circular functions of an angle given point in its terminal side. So this, if it is cos, it is cosine theta, or the cosine theta is equal to x over r, or the cosine is equal to x over r, or the adjacent over hypotenuse. And for sine, it is the opposite over the hypotenuse, where our r there is not equal to 0. And our tangent, it is y over x, where x is not equal to 0. And for secant, it is r over x, since it is the reciprocal of cosine, so it is r over x, with where x is not equal to 0. And for cosecant, it is r over y, where y is not equal to 0. And cotangent is the reciprocal of tan, which is x over y, where y is not equal to 0. Okay, next. Next one is so this, if the given circular functions is not equal to 1, so how can we determine the r? So to determine the r, let us write, or let us determine it by the Pythagorean theorem. So the Pythagorean theorem, it is the square root of x squared plus y squared. So this is now our formula. So let r be the distance from the origin to the point x and y. So it is the point, yeah, this is the point. And then point x and y with respect to the main axis. Hence, by the Pythagorean theorem, r is computed as r is equal to the square root of x squared plus y squared. So this is now our computed to get the r if the given radius is not equal to 1. For example, draw an angle of 60 degrees in standard position and evaluate the six circular functions of the angle. So for this example, since the coordinate of the angle 60 degrees in the unit circle. So we draw a unit circle. And this is our 60 degrees. So if it is our 60 degrees, so our coordinate for this 60 degrees is 1/2. So our 60 degrees is 1/2 and square root of 3 over 2. So this is our coordinates of the given angle 60 degrees. So therefore, so if the given is, if the coordinates is, if the coordinates, wait, if the coordinates is 1/2, 1/2, no, wait, 1/2, 1/2 and square root of 3 over 2. So this is our coordinates for 60 degrees. So how to find the circular functions of the value 60 degrees? So to find, so let us first determine the sine 60 degrees. So the sine 60 degrees is equal to, since if this is the given angle is in unit circle, always remember that in the unit circle, our radius is equal to 1. So therefore, our radius is 1. So our hypotenuse is 1. So now our 60 degrees. So see, it is sine. Remember that sine, the ratio of the sine, it is the opposite over hypotenuse. So our opposite, if this is the given angle, so our opposite is the y value. So y value. The x and y value, remember. So if it is the opposite of 60 degrees, it is the y value with respect to y axis. So our y is square root of 3 over 2. So square root of 3 over 2 over our hypotenuse, which is the 1. So how can we simplify this? So we can simplify this as square root of 3 over 2. So our sine 60 degrees is equal to square root of 3 over 2, which is correct in the unit circle since the sine of 60 degrees is square root of 3 over 2. For cosine of 60 degrees, so the cosine of 60 degrees is, this is the cosine of 60 degrees. So the cosine of 60 degrees, it is the adjacent over hypotenuse. So our adjacent with respect to x is x. And our 1. Therefore, our x is 1/2. No, wait. Square root of 3 over 2. And here is 1/2 over 1. So simplify this as 1/2. Therefore, our cosine now is 1/2. Next is tangent. Tangent 60 degrees. For tangent 60 degrees, since the ratio of tangent is the opposite over hypotenuse, or the opposite is the y, and the adjacent is x. Therefore, substitute the value. So our y is square root of 3 over 2. Wait. Square root of 3 over 2 over 1/2. Over 1/2. So to simplify this, it is the reciprocal. So if it is the to divide the fraction, we reciprocate the divisor or the denominator and change um the we change the division into multiplication. So therefore, this is now our square root of 3. Wait, square root of 3 over 2 times 1/2, right? So therefore, our tangent now is square root of 3. I know the reciprocal, so it is 2 over 1. This is now our 2. Wait, it is 2 square root of 3 over 2. So since it is mas-simplify pa natin siya. So we can divide 2 and the denominator 2. So we can cancel out. So wait. No, wait. We can cancel out. So cancel out natin. So ang mangyayari, ang natira na lamang is square root of 3 over 1 or square root of 3. So this is now our tangent. Next is um, cotangent. Next is cosecant. For cosecant, wait. Next is for cosecant. For cosecant, since the reciprocal of the ratio of the cosecant, it is the reciprocal of the sine. So since our sine while ago is um our sine a while ago is square root of 3 over 2, therefore our y is square root of 3 over 2. Square root of 3 over 2. So again, change the division into multiplication and reciprocate the denominator to simplify. So 1 times 2 square root of 3. Therefore, our cosecant is 2 square root of 3. Is this our final answer? No, since the denominators is in radicand. So we can simplify it by multiplying the both side by the square root. So we can call it is to rationalize to simplify it, this is to rationalize the number. So by multiplying itself, so multiplying itself by 2 square root of 3 times square root of 3 both sides, since we rationalize it. Therefore, our final answer is 2 square root of 3 over square root of 3 times square root of 3 is square root of 9. It is perfect square, so it is 3. This is now our final answer for cosecant 60 degrees. Next is for secant. For secant, wait, let me erase first. For cosecant, since secant it is the reciprocal of the x-axis, the reciprocal of the cosine. So therefore, our cosine is x. So therefore, our x value is 1/2. So again, to simplify this, let's reciprocate the denominator and change the sign into multiplication. Change the operation into multiplication. So 1 times 2 over 1, or simplified as 2. This is now our second. For cotangent, 60 degrees, since our cotangent is the reciprocal of the tangent and our tangent is y over x, so our cotangent now is x over y. Where of the value of x, substitute the value of x and y. So x is 1/2 divided by the square root of 3 over 2. So to simplify this, let's change the operation and reciprocate the denominator. So 1/2 times 2 square root of 3. So it is 2 square root of 2 over 2 square root of 3. So since it is simplified as cancel out 2, therefore it is equal to 1 over square root of 3. Since it is that the final answer, we can rationalize it by multiplying both sides by square root of 3. So our answer now is square root of 3 over 3. This is now our final answer. Next example, find the six circular functions values of an angle theta in standard position whose terminal side passes through the point 5 and 12. So passes the point 5 and 12. So if this is the given, so always remember, if the given is in angle, and if an angle, so therefore you can use the formula of the circular functions where r is equal to 1, since the given is angle. So if the given is angle, you can see, or you can remember that it is located in the unit circle. So it is, you can determine it in the unit circle. So you can use the formula or the ratios of the six trigonometric functions in the circular functions where r is equal to 1. If the given is like this, in example number 2, the point is given, therefore the radius now is not equal to 1, since the given if the since the given is point. Therefore, we can use the formula of the six circular functions with r is equal to 1. So first, let us first derive or determine the value of r using the Pythagorean theorem. What is the formula again of Pythagorean theorem? It is, no, wait. It is r is equal to the square root of x squared plus y squared. So substitute the value of the given point. So r is equal to x is 5, so 5 squared plus the square of negative 12, the y value. Therefore, r is equal to x. 5 times 5 square is 25, and plus if we square negative, it is positive. So the square of negative 12 is positive 144. Therefore we can change the sign, addition. So our r now is 25 plus 144 is 169. And remember, 69 is, remember that 169 is a perfect square. So the square root of 169 is 13. Therefore our r is 30. So the given now, we already determined the given. So our r, wait, our r is equal to 13. Our x is equal to 5, and our y is equal to negative 12. So to get the six trigonometric functions, the six circular functions, let us first determine the cos, wait, cos. So for cos, it is x over r. So our x now is 5 over r is 13. So this is now our final answer for cosine theta. We must put the angle given, the given angle. So it is cosine theta. So cosine theta is the ratio is x over r. So final answer is 5 over 13. Next is sine. For sine theta, it is y over x. Y over r. Sorry. It is y over r. Therefore, our y is negative 12. And our r is 13. Therefore, this is our final answer, negative 12 over 13. For tangent, it is y over x. So our y value is negative 12 and x is 5. Therefore, our final answer is for tangent theta. Sorry, I forgot the angle. So it is negative 12 over 5. The last three, the cosecant, the secant, and the cotangent. So that is theta, theta, and theta. So to determine this, these are the reciprocal of the primary, what do you call this? Primary trigonometric functions. So to get cosecant theta, that is the reciprocal of the sine. Therefore, it is r over y, or our r is 13, and our y is negative 12. So final answer, it is negative 13 over 12. Next, for second, it is r over x. So our value is 13 over 5. This is now our second. For cotangent, it is x over y. So our cotangent now is negative 12. I don't. It is 5 over negative 12. So this is our final answer, negative 5 over 12. Thank you. I hope that you have knowledge, or I have explained furthermore, or I have explained it um, concisely for you to understand. And thank you, and God bless.